Okay, so I think it's already started. Let's begin. Uh, the course content which we're trying to cover for today is about, as I told already, JDBC, which stands for Java Database Connectivity, and the actual database. So first we'll start with the SQL overview. So SQL stands for Structured Query Language. So every database like has SQL to connect to it to execute queries, etc. So to to create data structure or to insert data in that particular structure uh, that is table, we have SQLs. Okay, and when you create tables, so basically what you're doing, if you think from the overall schema perspective, and schema is like, say, a database. What is a database? So if you see database, it's just a server, right? Database is just a server. Why? Because I mean, it is like any other application server or anything else, because it has code to be run, it has data to be stored, it has data to be retrieved. So all this work is the work of a particular software, which is a sort of server running somewhere on a different machine. All right, and to connect to it, what we use is SQL. When I say connected, I mean like to interact with it. Okay, and SQL as such is one of the SQLs is DDL, which stands for Data Definition Language. All right, and this basically means, we think from the database perspective, we are changing something in the database, right? Because you are creating a table structure, so it's not like you're just inserting data into it, you are creating altogether different structure, you're defining how the data will be stored. And that's why everything which is related to, like, say, creating a table, altering the column of a table, etc., which stands for, like, you're changing some way in which the data is structured. All right, you're changing the data definition. So that's why such things come under DDL, which stands for Data Definition Language. So any query which is used to create tables, or maybe modify tables, drop tables, so such things come under DDL. And if you're trying to insert data, because you're manipulating data, right? You're updating rows, all these things comes under, or you're deleting rows, all this thing comes under data manipulation language, which stands for DML. So in common lingo, whenever someone says that, like, we are writing a DDL, that just means that we're writing something to change the structure of the data. And if we're writing DML, that means we are just trying to, the structure is already out there, we're just trying to insert data in that particular structure. All right, so as I mentioned here, DDL stands for Data Definition Language. This is used to create changes in the structure of the data stored in the database. Creating table is an example of data definition language. DML stands for Data Manipulation Language, and this is used to add data to the already created data structure. All right. Now, say if you have multiple tables, right? So what happens is, like, any database which you take for an example, like, say, MySQL, or maybe say Oracle, or DB2, or whatever. uh, it has different structure, right? And it may so happen, and I think most of you might be aware as well, it may so happen that the data which you want is on a particular certain condition. All right, and you it will be retrieved on the basis of certain query, and that query, it's a bit complex. I mean, it has to be run again and again, but it is a bit complex. It involves multiple tables. All right, so it may involve, like, say, employee and login table. All right, it may involve employee and login table. If it involves these two tables, then there are multiple conditions which get satisfied before a row of data is returned. All right, and then what needs to be done? Then you can write the query, but that query has to be kept somewhere, right? And you need to execute it again and again. Now the thing is that what you can do is that you can create a view. View means, like it stands for, it's just a view. So it's an assembly. Okay. So, like, say, to give a particular way to the user, you write queries in such a way that employee, okay, and login, they both are used, they both are combined on, like, say, where condition, etc., in such a way that you are able to get whatever you're looking for. Okay, so in the view, like, say, in the select part, if you want to select, say, uh, employee name, all right, and maybe say login details, all right, maybe all the login details of the customer. All right, maybe say login dot user ID. All right, and then say login dot password. So to retrieve these things, the condition is that the employee ID should be is equal to login ID. Just very simple example. All right. So in this case, if you want to retrieve, you can write the same query again and again. I mean, you can keep it somewhere. All right. So if you can have queries something like this: select emp name blah 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 uh, from employee, and you can give an alias, that is this is used to represent this name, like our names are our aliases, right? So just to represent employee table, you're using emp. For representing login, you just use maybe not login, maybe say lgn. All right, and then you map it here. So you can store this query somewhere. All right, or execute this query like in the form of a view. You can create some view out of it, because this query is supposed to always give you these three fields. So instead of like executing the same stuff, you can create a view, something like say create view as, and then write this entire query. All right, in fact in views you can even pass parameters, but let's not go out till there. But let's see, this is how it is there. Now create view, and then you give the name as like say login underscore details. Now every time if you want some data from it, you can just do say go here and do select say star from login underscore details. So you can query this as you can query a table, and you can get all the details. You can query this, as you query a table as well, right? So you can do where, and here you can query on the basis of whatever you get from here. All right, so whatever details you have here, so maybe where name is equal to say one of our students name, like say Usha. All right, so this is how you write the query, and this is how you get the details from it. All right, so this was what view was all about. View is a virtual table. We can create a view using various tables depending on certain condition. All right. Now database transactions are ACID, which means that database. If you're trying to execute, like say, a number of queries at a time, and maybe one query, like say, insert into uh, employee table, and while trying to do that insert, if that insert fails, all right. So the database has multiple columns as well, right? So say employee table has, as we're describing here, ID, right? So employee table has ID, it has name, it has like say or department ID, etc. Now, if you're writing an insert statement to insert all these details, and after writing like say just the uh, employee ID, all right, we're just writing the name, the database connection fails. The database server goes down. What happens? Uh, does your the data which you're trying to insert remain in the same way? The answer is no. Database employs number of ways in which it can avoid such things. All right. So, for example, say every time when you're trying to insert a data, after a certain point of time, you write something in the commit logs. All right. So there are log files as well, which database maintains for its own to find out till where it has to go if there is some kind of shutdown happening, or there's some kind of unexpected activity happening. So basically, every transaction database is durable. All right, it's very much consistent. You won't find, like say, if there are joins, there are foreign keys, you're trying to insert in one table, and the other table if you're trying to insert and it goes down, it will revert back from both the places. All right, so that's what stands for atomic, consistent, isolated, and durable. And it also gives you commit and rollback statements to do it from your end. So if you're trying to run, like say, a number of statements in the starting, right? Say if you're trying to insert some data in the employee table, after that you're trying to insert some data in the login table, after that you're trying to retrieve some statement. Depending on that, there's some common employee underscore login table, you're trying to go there and update something else. If that is your requirement, all right, then you can avoid doing commit until the last moment. All right. And if you find any errors, once you once you're if you have to insert data in employee login underscore details, and once you cross login underscore details part in the query, and only then you find that okay, fine, my all the work is done. After that time, you can just issue a commit statement. All right. So then whatever you have inserted before it will get stored. Otherwise, it will get rolled back by if you want to use this rollback command. All right. Now, this thing is generally not available with normal developers unless it's your local database or something. But on the database schema or the objects which you're using, the DBA can give you grant access or he can revoke access from you. So if you can grant an access to you, it can be like say grant, read, write, whatever on this particular table to all these users. All right, and these users generally they do not give it to a particular individual. They generally give it to a group, and in the backend they keep on adding users to that group if required or removing users from that group, so that they don't have to like uh, run this particular thing again and again. I mean, this statement just to avoid that. And similarly, you have revoke when you are like say leaving the company, or if you are moving away from the database module to some other team, then in that case you'll go ahead and revoke your access from there. So that's what you use. Grant is like this: grant privileges on table to the users, which comes here. And similarly, we have for revoke. So you grant revoke these privileges on this particular table from all these users. All right. Now, for our like say tutorial perspective, what we're going to use is MySQL. It's an open source database. You can go on the site. Some of you might be having Mac, and for that reason the installation steps might be different from the Windows one, and that's why I've mentioned both the links separately. But just go there and install it. All right. And if you install it, like don't install just the client, because say database anywhere, like it works in the form of a client server relationship, right? So there is a database server which has all the details, and if you have worked in QA or anywhere else, you must be having Toad or SQL developer to connect to this database and get all the details. And then from your code you have all these credentials like user ID, password, and the URL, and you try to connect to this particular to this particular database. All right, so your local PC is the client. All right, and your the server where actually the database is there is the server. But while installing this MySQL, you will install the complete package, because what you will do is that you will also install the server in your local, right, and you will try to connect to it, and the URL will be localhost, and maybe the port number is 1521. So that's the way you will do the connectivity for MySQL. All right, and then like say run some DDLs, like say create employee table, run some DMLs, insert some data into it. So that should be pretty much intuitive. All right, but what I'm trying to stress here is that uh, both the client and the server will be there on your own PC, because your own PC is also the database server, and because all the actual data will be stored there, and it will also be a client. All right, so that's how it is going to be. Now let's go below. So, and the other thing is that since like say you don't have to deal with this in your normal day-to-day life, I think as an IT professional, because there is a DBA and there is a separate DB server. But in your local machine, like when you're trying to access the MySQL database which you have downloaded and installed, you need to start it. You need to go to the bin folder, find the start.bat or maybe start.sh and start it, because the database server has to be running before it can be accessed via your client module, via your Java standalone program. So you need to go ahead and access it. You need to go ahead and start it. So that's what I've written here, that if your system shuts down, if you close your PC, your DB server will also shut down, because it's running there itself. And you have to start it independently by going to the bin folder, finding the start.sh or maybe start.bat. So bat is for Windows, and sh I think you can run from the terminal which you have in the Mac PC. All right, so the reason why we chose MySQL is because, and again, it's open source, very easily available, there is no licensing cost. So that's the reason we have chosen it for our tutorial. And in fact the usage is not much, I would say, like across the industry. But as a database, it has been gaining a lot of popularity, and there are some production scenarios where people have started using MySQL. So it's not like, I mean, first of all, it's not quite different from DB2 and Oracle. I mean, they all follow a similar structure, the similar way to write queries, similar way to connect. The only difference is the licensing, the underlying code, etc. But on the outer world, it's all the same. All right. Now, say what I have done, and I was explaining here, right? So once you create this table, once you create that schema, and whatever has been written here, I mean, if you go here and say, to go here and say, see this one, these two links. Yeah, but we are using MySQL only because the database server is also free. So say if you have this one, like say these two links. So uh, one is for Windows and the other one is for Mac OS. So you can use either of these links for installation. And once you create the server, once you create your schema, you can run all these queries whatever we have done here. Like say customer. So and create table. So create table is sort of you're creating a definition, data definition. So it's a DDL. All right. So create table customer. You have like say 4 or 5 fields you're trying to add, and once you create the schema, you can directly take it up and run this particular command, insert data into it. So if you're trying to create a customer table, we have a customer ID field, then we have first name, then we have last name, and then you define a primary key. So primary key, whatever has been defined here, you can just define like before this comma, if you give a space in primary key, this customer underscore ID will also come as, what do you say, it will come as the customer, it will be termed as a primary key. So primary key in a table is something which, first of all, there is a way in which data is accessed. So if you see and think from the real world perspective, like say if you have data, how, like even if they show it relationally to you, how is the data stored in your PC? I mean, it has to be stored in files, right? And if it has to be stored in files, when you run a select command, how does it know in which file it has to go and try to search, and like where your data will be? So all that thing is possible because the database internally uses a concept called as indexing. So it indexes certain fields in some way that it finds that if the customer ID is this, your data is present in this particular file. So that's the internal representation. But from your end, what is visible is that if you are marking a particular field as primary key, that particular field automatically becomes an indexed field. Okay, so you don't have to do anything else. Okay, second thing which comes for guaranteed is, and whenever you mark that field as primary key, that field will be not null. You need not write it specific. So the primary key determines these two things. So primary key is basically saying that when you're trying to access data, this will be your individual, your sole individual key which can be used to access a row uniquely. Okay, and the search etc which you do will be fastest using the primary key. Okay, and you can after creating this table, you can create separate indexes as well, like say create index on say first name also, because you are doing a lot of name searches on first name. So you can create a name, you can create an index on first name as well. So it depends. I mean, you can create indexes on combination of fields, like say first name plus last name, or only first name, or you do not need such indexes. In that case, you only have it in customer ID field. So all this thing is possible. It only depends on what your data structure is and how it wanted to be out there. All right. So using this particular DML, we're trying to, sorry, DDL, we're trying to create the customer table, and then we are trying to insert data into it using using some DML statement. Insert into customer, and you name the field values, field names here, and then insert the data. All right. And this thing, whatever I was telling right now, I mean, say if you have this field, if you are inserting the same number of columns as defined in the database, like say here you have customer ID, first name and last name. So here you have customer ID, first name and last name. In this case, since it matches exactly with the column structure which you have for that particular table, this thing where you have mentioned the column name is not required. This is only required when the number of columns in which you're trying to insert data is less than the number of columns which is present in the database. So say if the customer table has three columns, right? Customer ID, first name, last name. So you have the customer ID, you have the first name, all right, but you don't have the last name. So you write insert statement in such a way: insert into customer ID, comma first name, and just insert one comma Abhishek, all right. So in that case, last name would be blank. I mean, that will throw error because of here, but I'm just doing an example that that's possible. If you remove this not null constraint, you'll be able to insert data into customer table. All right. So only in that condition, this particular part is, you can say, relevant. It's not going to throw any error anyways. But if you have, like, say, hundreds of columns, and if you are having all this data, this is not required as such. It's going to be an additional hassle. But it all depends. I mean, I generally write it if because the tables which I generally deal with are like the small tables, maybe 5 6 columns are there where I need to insert data. So I'll write it individually. But if you have to insert an entire row, I mean, it doesn't make much sense. All right, but I mean, database is not going to stop you from doing that. Now, say, as a name is there, JDBC, so that stands for Java Database Connectivity. So what this means is that Java provides you an API, application programming interface, a set of methods to connect to database. All right, and that is JDBC. Now, so this is the architecture of how it is out there. So this is the part which is a Java application, and this Java application can be anything. It can be a stand-alone Java program, like, say, whatever you go and write in Eclipse just with the main method. It can be your complete like web application archive, or like whatever is used to create web applications in the real production world scenario, or it can be an applet, something which Java provides you for creating UIs. So it can encompass various different stuff. So it just means that it's a Java application, and whatever is out there, all right, whatever is out there has nothing to. I mean, there is no distinction that Java applet will connect in a different way, or say. Uh, no, I mean, the standalone Java program will connect in a different way. There is no distinction as such. I mean, there is one layer. There is JDBC API interface, which means application program interface is out there. You code according to it. From wherever you code, it doesn't matter. The API remains the same, and then using that, you can contact the actual database. So we see here what we're doing is that there's a driver manager class. You always interact as a Java application. You always interact with this driver manager, all right. And then depending on what you are using, like what type of driver you have, because JDBC requires that, say, it's a very fluid kind of architecture. All right. So if you try to understand, it is something like this. It is something like this. Say you have a Java application, all right, and Java application is always trying to connect to an API, and this API definition does not change, all right, and you as a developer are always interacting with it. Okay, so you're trying to get a you're trying to connect to DB from it. You're trying to run query from here, maybe DDL, DML, whatever, and then you're trying to close connection or whatever else you want to do. You can do it from here. So this is how this works. So you have a Java application that connects to an API. This API definition does not change, but in the backend, this API, the way in which it works is that you have an API that interacts with different kinds of drivers. So depending on database, you will have drivers, because every database is different, right? And they have their own API set specific. So for MySQL, you have a different driver which comes in. For Oracle, there's a different client driver. For DB2, there's a different driver. So there are different ways to connect to this database, and that's why the driver changes. And when I say driver, it just means it's a jar file, Java application archive. So it's like set of Java programs together. And I think we discussed about jars before. So it's nothing more than that. It's just, set of common files which are put together in a zipped format. Basically in .jar format, which is called a jar file, and we use that. So that is called as a driver. All right, and we use a driver to connect to the DB which is there. All right, now this driver can change because this depends on MySQL. All right, this depends on Oracle, this depends on DB2, but the API definition does not change. So say if we did not have this kind of architecture, what would have happened? Now your Java app, if this kind of architecture was not there, your Java app would have tried to connect directly to the DB using their interfaces, okay, their code connectivity methods, which can be different for MySQL, which can be different for Oracle, which can be different for anything else. Okay, so that's how it's going to be. Okay, so it's different. So for Java to JDBC, so connection method is Java to driver manager, driver manager to driver, okay, and driver to database. So this is how we connect it. So this is a fluid architecture which we have, and this helps us that we do not directly interact with the driver, because the driver can be different from database to database. And if you remove the driver, your code will be directly dependent on the actual database. So your Java code will be having something specific to MySQL. Okay, and tomorrow if you think that MySQL is not your cup of tea, it's not scaling up, there's a new database which you want to use, maybe the relational database itself is not for you, you want to use something which is like say NoSQL, you want to go ahead with Cassandra or whatever. In that case you will have to go ahead and change it here, because this driver this driver might be different for the different database which you're trying to inject now, which you're trying to use now. So your code is directly dependent on the driver, which should not be the case, because it makes your migration to a different database or maybe to different versions difficult, because you have to go ahead and do the coding changes, etc. And there is very tight coupling between whatever you are doing and between whatever is underlying. All right, so there are different, either you use a vendor specific JDBC driver and connect to the database, or there is another JDBC ODBC bridge, and ODBC stands for, I think, open database connectivity. So again, there is a separate kind of jar file which is out there. So this driver manager always interacts with this one, then this interacts with the vendor specific ODBC driver, and then this interacts with the database. So the way in which the interaction happens from below here, this is not an user is exposed to. Okay, so JDBC architecture decouples an abstraction from its implementation. New drivers can be onboarded without changing the driver manager interface and thereby the client code. All right, and the driver manager provides a consistent layer between your Java application and backend database. And design pattern which is used here is bridge design pattern. All right, so if you see whatever I was describing here now, this driver is a sort of bridge, right? Because you don't have to, this is like of no business significance to you. Java as an application always has to connect to DB, all right? So if you have here, you have like say driver manager, and you have drivers and you have database. So Java has to deal actually with the drivers, the client, the connectivity code which you have, but you go via driver manager. And why this is so? This is a bridge. Why? Because it decouples an abstraction from its implementation. So what decouples an abstraction from its implementation, meaning that you have an API, you deal with that, and driver has the actual implementation. All right, and the bridge pattern basically means that you are trying to use something which is used to smoothen out the entire process, but it actually doesn't serve any business value. Like say driver manager, it's a sort of bridge for you to going to the driver. But you have this bridge because this bridge is same for different kinds of databases. So the design pattern in play here is called as bridge design pattern. All right. Now say, how do we connect to a database? So the connection to a database involves multiple steps. All right. First, let's think what all we should do. So you have a database, and uh, you first need to connect to it, right? Because it is something out there, but how do you execute certain queries on it? Well, ultimately, whatever queries you fire from your Java code has to get executed on that particular database itself. So first you need to connect to it. Then you need to write some statement in your say Java code, like say select customer ID from customer, where customer name is Asha or whatever. Okay, so if that is the case, so in that case you write a SQL statement, then you fire them. So basically it goes and executes on your DB server, and then it gets a result set. And once you get the result set, you are satisfied that I wanted to know the customer ID for the customer name Usha or Asha, and you got that result. Now this connection is redundant, I will close it, because connection is basically you're trying to run some queries, right? So it can also bring down the DB server if the number of connection reaches a maximum, and you all are trying to execute queries. So it is like a normal application. There's not much difference, right? Now say come below. So when you try to establish a connection, what do we do? So first thing to do, say now the driver manager connects to different drivers, right? So how does it know which driver to connect to? So the thing is that when you do class dot for name and give the driver name, now this loads up in the memory, okay, and after when you're trying to connect using the API, the driver manager, it automatically knows because it tries to find for the driver implementation, all right, and one of the driver implementation is this driver, which is like say I mean very much upfront in the memory. I mean it's searchable. It's able to find this driver class, so it loads this driver class and executes any and it executes any query which you are trying to find. So driver manager, how does it find which driver to contact with? Because first of all you run this particular line class.for name and give the driver name. So for MySQL, this driver name is going to be different, all right. And if you do this, and it loads this particular class in the memory, and in the next step, when you're trying to connect to it, connect to the database, it knows that which driver to use because that driver is already there out in the memory. Okay. Now, first thing is to load the vendor specific driver. This is a statement. This loads the class Oracle driver, executes any associated static block, and returns the instance of driver class. So class with for name not only like it will load the class, then so whenever you load a class, so any static block which is out there, not static methods, but say class level static blocks, they are executed at the same time itself. And this particular name, say class.for name, is going to return you an instance. Although in this case we do not use that instance, but I mean this is not only specific for JDBC, right? It can be used for multiple purposes. So class.for name in different contexts, I mean you can use it for creating an instance, and that's where it can be used. All right. So here also it returns the instance of driver class as anywhere else you want to use this particular class.for name. Now this ensures that the implementing class is loaded in memory in JVM and is available while trying to make connection to the database. Now second step, now this is like loading the appropriate jars in the memory, loading the appropriate class in the memory. And the second step is actually doing the connection. So if you go above and see what are the steps which we had listed was, you establish a connection, create Jdbc statement, execute them, get the result set, close the connection. So this is how we are doing the connection. All right. Now if you come here and say second step is to make the connection. So if you do the connection like this, driver manager.get connection, you give the entire you give the entire URL here, and this URL depends on what is out there in your local, all right, and you give the user ID and password. So this creates the actual connection to the database using driver whatever you had loaded before. So using this is a driver which is being used, all right, but you don't mention all this thing here because again, I mean, it's a API which we are using doesn't know about the underlying, it doesn't expose anything about the underlying drivers. It just gives everything upfront here. All right. So you give the driver manager.get connection, you give the URL, you give the user ID, you give the password, and this establishes a connection with the database server. All right. Now, what you do is that you create the actual statement and then like run it, right? You create a Jdbc statement. Such statements represent the actual DB statements. For executing stored procedures, we have different kinds of statements, and I have put like one of the assignment questions regarding it so that you can go and find it out, because unless you try to research from your end, you're not going to learn about it. So there are different kinds of statements which Jdbc provides you with. One is statement, one is prepared statement, then you have callable statement. One of these is used to execute stored procs from the Java code. One of these is used to have this particular part which I have mentioned here, but it is up to you to find out what. So if you want queries to be pre-compiled and there should not be any time lag associated with it, I mean there is a mistake from here my end. There should not be any time lag associated with it, because whenever you execute a queries, first of all Oracle, MySQL, whoever tries to compile it, right? It tries to find out whether the query is fine or not. Then the next step is execution. So if your queries are pre-compiled, you save on that time, however small that is, but you save that time. And if your queries are complex, it is big, it is not on a non-indexed field, it takes more time. So you can avoid that time, because anyways, I mean once you run it, you know that this can be compiled. So you do not need that extra compilation to be run every time. So there is a separate kind of statement which can be used for it. All right. And the hint is you have three kind of statements. One is statement class, one is prepared statement class, one is callable statement class. Now, now you have to execute the actual Jdbc statements. So for that, JDBC API, the Java Database Connectivity, has given you uh, it has given you a class. All right, that class is statement class. So you can use the statement class to actually write that particular SQL statement, and the connection object which you created before. All right. So if you see the steps which are there, what are the steps? So the steps are, so the steps are, first of all, you do class dot for name. All right. Second step is you get the connection object using driver manager dot get connection. Third step is using the connection object which you got in this step, you do connection dot create statement. All right. So this is what we have done till now. Now going back to the PDF again. Now once you have, and it provides you different APIs. All right. So if you see here, you have statement.execute query. Now execute query, what it does is that whatever is a query out there, it executes it. All right. It's very simple, but it can't be used for, like, say if you are running, say, update customer, set first name is equal to, say, say first name is equal to Abhishek, where last name is equal to Singh. Now for all the customers for which the last name is Singh, you want to try to update the first name to Abhishek. This is a weird requirement, but let us assume that this was a requirement. So this is the case, you can't use execute query. Okay, because execute query is generally used to run only the select statements. Alright, so it gives you various APIs. One is execute query, which is used for running select statements. Alright, and for running any DDLs or update or insert statements, you use execute update. Now this is the one which you use for inserting data. This is the one which you use for updating data. This is the one you use for running DDLs as well, I think. Alright, so if you see, the next step is to execute the query using a statement.execute query. Now you get the result set. Now result set is another class in Java. Alright, and this holds the first name for all the customers stored in the customer table. Alright, and this gives an API to iterate over all the data which it has. So if you see here, whatever is explained, I mean, it gives you result set dot next. So I mean, you can't just go ahead and iterate it like, say, a normal array you iterate, or a normal Java object you iterate over a list or a map using for loop. So that's not the way it is done here. You have to iterate one by one. Alright, so every time you'll get one instance, you do a next, then again you get some data, then again you do next, then again you do next, and you keep on doing that. So result set provides various APIs. One of it is like this, and then you get int, you write the name of the column which is here. Instead of writing the name of the column, if, like, say, if you have 100 fields and you know the order in which it will be coming, you can just write rs.get int maybe 1, rs.get int maybe 2, and if you know that it's a string, then instead of, say, like here it is, so in my case, I think it's my bad, it has to be turned into rs.get string, because in that way it knows a data type upfront, like what is the type of the column, what is the type of the data you're trying to retrieve. Alright, so going back here, if you see, so you create a connection, then you created a statement, and then you executed the query. Alright, and once you created the execute query, when you executed the query, the next step is to get the result set and iterate over the result set to find out what data it is. I mean, you can run the queries for multiple things, right? You can just be checking what's the count, whether data is present, not present. It depends on a requirement. You can do multiple things. Alright, so this is what is out there for result set. Now, to insert data into the table or to even create a table, we need to use execute update API, as I was telling. Now you can say insert into customer, you can create this insert statement, alright, and then say execute update. And we are writing this backslash because this double quotes, I think, is not like here, because we are also using double quotes here. It will try to close it here, and your string statement, your string data type will not be complete. So to say that this needs to be avoided, I mean, it used to be as it is, this is not signifying closure of the string, we give this backslash. Alright, and then you use this execute update to insert data, and I think it's used for even doing the DDL part. Alright, and the last step is that you close the connection object, you close the statement object, and then you're done. Alright, so once you have iterated to the result set, whatever is the statement you have created, that statement object, you can do close. Alright, and if you have done any, say, what is a connection object which is open, you can do connection dot close. Alright, so these are the steps. Normally you'll find all the steps mentioned in one particular Java program. I've distributed it because so that you can go ahead and write it one by one depending on your database and try to connect to it. Alright, now coming to JDBC drivers. Alright, so since the driver code as well, like whoever is writing it, you are writing it because you do not write it for, when I say you are writing it, you don't need to write it for connecting to a database. But see, if you're a Java developer, you're working for another database company, whatever, ABC, and they are trying to come up with their own drivers, then you can do it, right? So there is a standard set for those drivers as well. There are four types of drivers. One is called as type 1, the second one is type 2, then type 3, and type 4. Alright, so type 4, if you see, is a native protocol pure Java driver. So this means that, I mean, uh, you like say, to connect to any database, you you need to execute their native code, right? You need to execute that native code because that's how it's written. So they might be using C or any other language which they think is a better fit for writing their application. And if they're using those APIs, they will provide a way to connect to it. And using the native, you can execute native code as well from your Java code. Java provides that facility. So if you connect to that native code, so your work only ends while trying to connect to that native code. Rest of the work is done by the actual native code which is provided by the database vendor. Now think from this perspective, they know the database, they know how to connect to it, so the API which they will be providing will be the fastest possible API, alright, to connect to it. So that's the reason that type 4 JDBC driver is one of the drivers which is used most often. Alright, it's used most often. The second one which is used is type 3. So type 3 is like say server side middleware. So somewhere you have server, you talk to that middleware. So they have exposed some APIs, you talk to them, that API in turn goes back and tries to connect to DB. So it's also a good way to write it. The only thing is that it will take a bit more time because you do not connect directly with the native protocol. You connect to the server side middleware, they connect to the native protocol. So there's an extra layer which is in between, which is going to slow down the things a bit. All right. Now, type 2 drivers. So type 2 drivers are that on client side as well. You have vendor specific native libraries. All right, and you try to just connect to that one. All right, and you try to connect to that particular native code, and it tries to do all the work for you. Or the fourth one is you only have the native code and you try to directly access the native code from your end. So this is a type 1 driver which is like this calls native code of the locally available ODBC driver. Now thing is that if you try to connect to this driver, alright, it is used only for development purposes because it's not so much scalable. Because tomorrow if your driver code changes and it has huge dependency, that's why it's not widely recommended. But if you have the development environment, you can use it there. Okay, in your local, for your local usage you can use it, but normally for production usage, it's not favored. Okay, so mostly whatever is favored is type 4. So this is the one which gives you the best of both the worlds. You can use a pure, you're using Java language, you're accustomed to it, and at the same time you are getting the benefits of almost the native protocol as well, because this combines the benefits of both. For accessing from your end, you have Java driver in place, all right, but in the backend, it directly connects to the native protocol, and that gives it the speed. So that is the type 4 JDBC driver. Now, if you don't have type 4, for whatever reasons, you can use type 3, but type 1 is seldom used, and if you don't have type 3 and type 4, you use type 2. So that is how the acceptance level is. Type 4 is preferred over type 3, type 3 is preferred over type 2, type 2 is preferred over type 1. Now this is for normal, like say if you have a database to connect to. Alright, so if you have an Oracle database and you always have to connect to an Oracle database, if you have a MySQL database and you always have to connect to MySQL database, then type 4 is preferred. Okay, so if you have one set of one kind of database we're trying to connect to, and there are applications, and there are huge applications which tries to connect to multiple databases, because some part of the application is in one database, the other part is in the other database, maybe audit logs is in some other database. So in that case, what happens is that you have to connect to different databases. So you, instead of writing this using this driver which connects to just different database protocols, because in such cases you'll have, like say if you use a driver manager, it loads a particular driver in memory, and you're trying to execute the native protocol, so you'll have to make distinction. You always have to load different classes, because different classes will be used for interacting with different databases. So it's still usable, but a slight difficulty would be there. To make it very smooth, you can go for type 3 drivers if you're trying to connect to different kinds of databases. Alright, so that is what I think I've written below as well. Type 4 combines best of both the worlds. We are not directly dealing with the native code, but we are getting the benefit of it via a standard high level language. So this is what is out there for Jdbc drivers. So in your normal day-to-day life, you will never be dealing with these drivers, in the sense that I never dealt with it as well, and none of my colleagues, because as a normal developer, you don't need it. Only when you are working on exactly on creating a database, exactly on creating something which is related to connecting to it, you need to work on writing the drivers. But otherwise, whatever is the database vendor, MySQL, Oracle, D2, etc., etc., they will themselves provide you the driver, and it's like free, because the client is always free, because the money is only for the server. So you can always have the Oracle client, D2 client, MySQL client, any client for free. The only charge is for the server, which MySQL also it's not there. So these are the different JDBC drivers which we're dealing with. All right. Now I think that should be the end of it. I don't know if I have anything else. No, that's true. So I have number of questions. All right. I'll like all of you to actually go ahead. There are some theory questions, and there are some practical coding question as well. It's for your own benefit, so it will be better if you go ahead and try to run this and try to work on it. So that is from my end. If you have any questions, you can ask.